Morning to all dear students. Now, in the last period, we will completed Ostwald dilution law. Now, today's period will take some problems depends upon the Ostwald dilution law. So, basically, Ostwald dilution law related with degree of dissociation, that is the alpha, and therefore Ostwald dilution law is useful to calculate degree of dissociation for weak acid and weak base. Second one, it is also useful to calculate K. K means that is the dissociation constant. So this dissociation constant may be for acid or maybe for base, means to calculate dissociation constant for weak acid or weak base. With that also you have to remember Ostwald dilution law is useful to calculate concentration of H plus ion or concentration of OH minus ions for the given solution, particularly for weak acid or for that is the weak base. And also Ostwald dilution law is useful to calculate the percentage dissociation. So in this way you have to remember these are the applications of Ostwald dilution law, and hence you have to remember by using Ostwald dilution law we can calculate degree of dissociation, we can calculate dissociation constant, we can calculate concentration of H plus or concentration of OH minus ions for weak acid or weak base, and with that also you have to calculate the percentage dissociation. Now we have to study one by one. So here for this there are some formulas are required. Now which formulas are required to calculate all these things? So here for weak acid, the formulas are number one Ka. K stands for dissociation constant and A suffix indicates that is the weak acid. So dissociation constant Ka is equal to alpha square C. Second formula, alpha is equal to, that is the square root of Ka upon C. Third formula is concentration of H plus ion is equal to alpha into C, or by substituting the value of alpha in this equation, then also you become a new formula or made a new formula, that is square root of Ka into C. So for weak acid you have to calculate dissociation constant, you have to calculate degree of dissociation, or you have to calculate concentration of H plus ion by using these formulas. Similarly for weak base, instead of acid, if you have to given the base and you have to ask calculate dissociation constant or degree of dissociation or concentration of OH minus ion, then it can be calculated as Kb is equal to alpha square C. So formulas are same, only instead of K, so you can write here Kb. Now alpha is equal to, second formula, square root of Kb upon C. Third, concentration of OH minus ion is equal to alpha into C, or substituting value of alpha in this equation and modified, then this equation becomes square root of Kb into C. So by using this formula you can calculate the respective quantity. With that also you have to remember general formula. The general formula are alpha is equal to percentage dissociation divided by 100. So this is the general formula that you can use for weak acid or weak base. Suppose for if 2% dissociation of weak acid or weak base is to be given, that 2 by 100 is nothing but it is called alpha or degree of dissociation. Or if you have to ask calculate the percentage dissociation, then this percentage dissociation is equal to alpha into 100. So these are the important formulae related to our syllabus. So by using this formulae you can calculate any asking quantity. So this is very important. Suppose instead of weak acid or weak base only electrolyte word is used for weak electrolyte, then instead of Ka or Kb, you can mention only K. And this K is called dissociation constant. So K is equal to alpha square C. Or if you have to calculate the alpha, then alpha is equal to square root of K upon C. So this is for weak electrolyte. These are for weak base. These are for weak acid. And these two formulas are general for weak acid or weak base. With that also, for two acids are given, then strength of acid Ha1 divided by strength of acid Ha2 is equal to square root of Ka1 upon square root of Ka2. Also you have to use this formula. So in this way you have to remember this formula. Or also, instead of acid base is to be given, then the same strength of base BOH1 divided by strength of base BOH2 is equal to square root of Kb1 divided by square root of Kb2. So these are the different formulas, and with that here you have to study which formula you have to use for the Ostwald dilution law, and by using this formula you have to solve some problems based on these formulas. Now we'll take some problems. So problem number 1. So very easy problems. So problem number 1 is a weak electrolyte is 2% dissociated. A weak electrolyte is 2% dissociated in its decimolar solution. In its decimolar solution, calculate its dissociation constant. Calculate its dissociation constant. Calculate its dissociation constant. So students, now here weak electrolyte word is given instead of weak acid or weak base, and therefore you have to use the formula K, because you have to ask dissociation constant, and hence this formula becomes K is equal to alpha square C. So by using this formula you can calculate its dissociation constant. Now here, which are the given quantity? So first you have to write given quantity. So given quantity 2% dissociation, and therefore with the help of 2% dissociation you can calculate alpha. So alpha is equal to percentage dissociation divided by 100. 2% dissociation is to be given, therefore 2 by 100, and 2 by 100 is nothing but 2 into 10 to the power of minus 2. Second, given concentration decimolar. Deci means 1 by 10, and 1 by 10 is nothing but that is a 0.1, and 0.1 is nothing but 10 to the power of minus 1 molar. So if decimolar is to be given, then you remember it is always 0.1. Centimolar is to be given, always you have to remember 1 by 100, that is 0.01. Of millimolar is to be given, then always you have to remember 1 by 1000, that is 0.001 molar. So these are the words used in the numericals. So here alpha is given 2 into 10 to the power of minus 2. Concentration is given 10 to the power of minus 1. You know the formula K is equal to alpha square C. Therefore alpha, you know, alpha is 2 into 10 to the power of minus 2 square into C concentration, that is 10 to the power of minus 1, and therefore K is equal to 2 square, that is 4. 10 to the power of minus 2 square is 10 to the power of minus 4 into 10 to the power of minus 1, and hence K is equal to 4 into 10 to the power of minus 5. So this is the dissociation constant of that given weak electrolyte, and it is the constant, therefore this constant has no unit. So in this way you have to complete the first problem. So in this way you have to remember how to calculate the dissociation constant. Now we will take the second problem on Ostwald dilution law. Now if dissociation constant of weak acid is 1.8 into 10 to the power of minus 5, calculate its degree of dissociation in 0.1 molar solution. Now student, in this problem dissociation constant is given. In the last problem you have to calculate dissociation constant. Now in this problem dissociation constant is given and you have to calculate the alpha, and for weak acid, and therefore the basic formula is alpha is equal to square root of Ka upon C. So this is the basic formula to calculate degree of dissociation for weak acid. Now here given quantities you have to remember, given quantities dissociation constant K is given 1.8 into 10 to the power of minus 5, and second one concentration C is given, that is the 0.1 molar. It's very simple. Now you have to substitute this value in this equation, that this equation becomes alpha is equal to square root of Ka, that is 1.8 into 10 to the power of minus 5 divided by 0.1. Now 0.1 can be written in the form of 10 to the power of, then it can be written like that. So first, as it is 1.8 into 10 to the power of minus 5 divided by 0.1 can be written in the form of 10 power, you can write 10 to the power of minus 1, then it becomes 1.8 into 10 to the power of minus 5 plus 1, means alpha is equal to square root of 1.8 into 10 to the power of minus 4. So student, you have to remember you can calculate the square root of 10 to the power of minus 4. This square root is 10 to the power of minus 2, and you have to see what is the square root of 1.8 in the log table. So in the log table square roots are given, cube roots are given, like that. So square root of 1.8 is 1.342. So 1.342 into 10 to the power of minus 2 is nothing but it is the degree of dissociation. So in this way you have to calculate degree of dissociation for weak acid. So in this way, so this is the second problem. So in the first problem you have to calculate dissociation constant. In the second problem you have to calculate the degree of dissociation. Now we will take third problem. So in this problem, third problem, the dissociation constant of weak electrolyte, instead of weak acid or weak base, suppose weak electrolyte is given, that is 4 into 10 to the power of minus 5. Calculate its degree of dissociation. Calculate its degree of dissociation in its 0.01 molar solution. In its 0.01 molar solution. Students, the same problem is here. You have to calculate the degree of dissociation. Concentration is to be given 0.01 and dissociation constant. So first you have to write given quantities. So given quantities, the dissociation constant K is equal to 4 into 10 to the power of minus 5. Second, concentration is 0.01 is nothing but that is the 10 to the power of minus 2 molar. And then you have to calculate the degree of dissociation. So what is the formula to calculate degree of dissociation? Alpha is equal to square root of K upon C Now we have to put the value of k and c here. So k value 4 into 10 to the power of minus 5 and the value of concentration is 10 to the power of minus 2. So on solving this equation it becomes 4 into 10 to the power of minus 3 minus 5 10 to the power of minus 5 10 to the power of plus 2 minus 5 plus 2 it becomes 10 to the power of minus 3. Now definitely students see this point carefully or listen this point carefully. The square root of 4 is definitely 2 but the square root of 10 to the power of minus 3 cannot determine, you cannot calculate, because if you have to calculate the square root then it is always in the multiple of 2, 2, 4, 6, 8, 10, 12 like that. So instead of 10 to the power of minus 3 you can convert it 10 to the power of minus 2 or 10 to the power of minus 4 and therefore it is easy for us to convert 10 to the power of minus 3 to 10 to the power of minus 4, and once it is converted into 10 to the power of minus 4 then this 4 becomes, that is the 40. So instead of 4 you can write 40 and therefore it becomes into 10 to the power of minus 4 and therefore now you have to calculate the square root of 40 into 10 to the power of minus 4. So 10 to the power of minus 4 square root is 10 to the power of minus 2 and 40 means in between 6 to 7 and in between 6 to 7 means 6.342 into 10 to the power of minus 2 and that is nothing but degree of dissociation. So in this way you have to remember this formula. So here second and third formula of same type, but one difference is here that in the third formula this while calculating the square root, so square root can be calculated like that. So 10 to the power of minus 3 minus 5, that such a square root cannot be determined. So it can be converted into next 10 to the power of minus 4, minus 6, minus 8 like that, and in this way you can substitute this value and calculate the answer. So in this way you have to complete here, that is the third problem to determine or to calculate the degree of dissociation. Now next problem is fourth problem, dissociation constant of 0.01 molar acetic acid solution. Acetic acid is 1.8 into 10 to the power of minus 5. Calculate concentration of H plus ion in the given solution. So this is the formula. This is the problem. Calculate the concentration of H plus ion. Now here dissociation constant is to be given and therefore in the solution you have to remember dissociation constant for acid, that is the Ka is 1.8 into 10 to the power of minus 5. Then concentration is given C, that is the 0.01 molar is nothing but 10 to the power of minus 2 molar, and here you have to ask or you have to determine the concentration of H plus ion. Now which is the formula to determine the concentration of H plus ion? So formula is concentration of H plus ion is equal to alpha into C. And here concentration is known but alpha is not known. But you can calculate the alpha. Alpha is equal to square root of Ka upon C. So K is to be given, concentration is to be given. You have to substitute this value in this equation and calculate the alpha. So when you substitute the value, so Ka is 1.8 into 10 to the power of minus 5 divided by 10 to the power of minus 2. 10 to the power of minus 2. आता वरी गेला तर 10 to the power of minus 5 plus 2, then this equation becomes now K alpha is equal to 1.8 into 10 to the power of minus 3. Now the same thing is here. Again 10 to the power of minus 3 it is converted into 10 to the power of minus 4, and once it is converted to 10 to the power of minus 4 then this 1.8 becomes 18 and therefore it can be written as 18 into 10 to the power of minus 4. And now you know the square root of 10 to the power of minus 4, ultimately 10 to the power of minus 2. the square root of 18 in between 4 to 5. 4 to 5 means 4.324. So in this way, you have to remember this is the alpha or degree of dissociation. But here you have to calculate the concentration of H plus ion, and therefore you have to write the formula. Concentration of H plus ion is equal to alpha into C. You know the alpha 4.32 into 10 to the power of minus 2 into concentration, that is the 10 to the power of minus 2, then it becomes 4.32 into 10 to the power of minus 4, and now unit is to be given, that is the moles per dm cube, because it is the concentration of ion, and therefore these are the answer. So concentration of H plus ion is 4.32 into 10 to the power of minus 4 moles per dm cube, and alpha is 4.32 into 10 to the power of minus 2. So in this way you have to determine the concentration of H plus ion. So this is the fourth formula, fourth problem. Now similarly you have to determine the concentration of OH minus ion. जसं आपण H प्लस आयनचं कॉन्सन्ट्रेशन काढलं त्याच पद्धतीनं आता आपल्याला कॉन्सन्ट्रेशन ऑफ OH मायनस आयनचं काढायचं आहे, आणि कॉन्सन्ट्रेशन ऑफ OH मायनस आयन्स काढायचं असेल तर आपण एखादा प्रॉब्लेम घेऊ. प्रॉब्लेम नंबर 5. At 298 Kelvin, a weak base is 3.5% dissociated. 3.5% dissociated in its centimolar solution. Calculate OH minus ion concentration. Calculate OH minus ion concentration and dissociation constant of, that is the weak base. Now this is a problem. Now here which quantity is given, that is the 3.5% dissociated. With the help of this you can calculate alpha. So alpha is equal to percentage dissociation divided by 100 is equal to 3.5 divided by 100 means 3.5 into 10 to the power of minus 2. Second is you have to calculate the concentration of OH minus ion. Concentration of OH minus ion and in its centimolar solution. C is equal to 1 by 100. 1 by 100, that is a 0.01 molar. So these two quantities are given, and with the help of these two quantities you can calculate the concentration of OH minus ion for that weak base. So here formula is concentration of OH minus ion is equal to alpha into C. So alpha is 3.5 into 10 to the power of minus 2 and C is 10 to the power of minus 2. So answer will be 3.5 into 10 to the power of minus 4 moles per dm cube. So in this way you have to remember that is the concentration of OH minus ion. And with that also here you have to calculate the dissociation constant. So dissociation constant, that is the weak base, therefore I write Kb. So Kb is equal to alpha square C. So you know the alpha is 3.5, you have to substitute value here, 3.5 into 10 to the power of minus 2 square into concentration is centimolar, that is 0.01 means 10 to the power of minus 2. Then you have to do square here, and this square is 10 to the power of minus 2 square is 10 to the power of minus 4 into 10 to the power of minus 2, and the square of 3.5 is, that is the 12.25, and therefore the answer is Kb is equal to 12.25 into 10 to the power of minus 6. So in this way you have to remember you have to calculate the concentration of OH minus ion as well as, that is the dissociation constant for, that is the weak base. Now next problem, here you have to calculate the percentage dissociation. percentage dissociation. So next problem is problem number 6. An organic monobasic acid is 2% dissociated in its 0.05 molar. In its 0.05 molar solution. Calculate percentage dissociation. Calculate percentage dissociation in its 0.1 molar solution. Now students, such type of problems are asked in the examination. An organic monobasic acid is 2% dissociated in its 0.05 molar solution. And you have to ask, calculate the percentage dissociation for the same solution. Only concentration is to be changed. That is, instead of 0.05 here, that is the 0.1 molar. And therefore, here, you have to first calculate the dissociation constant for acid. So, Ka is equal to alpha square C. Because dissociation constant is always constant for the given concentration, and therefore K is equal to alpha square C. Alpha you know, that is the 2 divided by 100, means that is 2 into 10 to the power of minus 2, and C concentration is nothing but that is the 0.05 molar. So you have to substitute this 2 value in this equation. That this equation becomes Ka is equal to 2 into 10 to the power of minus 2 square into 0.05. By substituting this value, it becomes 4 into 10 to the power of minus 4 into the 0.05. I can write 5 into 10 to the power of minus 2. And therefore, multiplication of these two, 5 4s are 20 into 10 to the power of minus 6. So this is the dissociation constant. But here I have to ask, calculate the percentage dissociation. Calculate the percentage dissociation in its 0.1 molar solution. And therefore you can calculate first here alpha. So alpha is equal to again square root of Ka upon C. Now here you have to determine K. K is always fixed for the same solution at different concentration. So alpha is equal to square root of K upon C. Ka is 20 into 10 to the power of minus 6. Upon concentration now here changes. Which concentration you have to give one, or calculate the percentage dissociation for which concentration? 0.1. 0.1 is that is the 10 to the power of minus 1. By solving this, so it becomes 20 into 10 to the power of minus 5. Minus 1 वर गेलं तर minus 6 plus 1 minus 5 झालं. आता 20 square root of 20 into 10 to the power of minus 5 त्याचा आपल्याला स्क्वेअर रूट काढायचा आहे. तर 20 चा निघेल पण 10 to the power of minus 5 चा निघणार नाही. आणि म्हणून ही व्हॅल्यू आपल्याला अशा पद्धतीने लिहून घ्यायची. अल्फा इज इक्वल टू स्क्वेअर रूट ऑफ 2. 20 च्या ऐवजी 2 लिहायचं, म्हणजे संख्या आपण ती छोटी केली तेव्हा 10 चा पॉवर मोठा होईल. minus 5 च्या ऐवजी तर 10 to the power of minus 4 लिहायचा. So 2 into 10 to the power of minus 4 meaning are same. 2 into 10 to the power of minus 4 is value is the same of 20 into 10 to the power of minus 5. But you have to write like that to determine the square root, and therefore the square root of 10 to the power of minus 4 is 10 to the power of minus 2, and square root of 2 is that is 1.414. So this is the alpha. So alpha is equal to 1.414 into 10 to the power of minus 2. But here you have to determine the percentage dissociation, and hence the percentage dissociation is nothing but is equal to alpha into 100. So this is the formula. Alpha you know that 1.414 into 10 to the power of minus 2 into 100 means that is the 10 to the power of 2. So 10 to the power of minus 2, 10 to the power of plus 2 will cancel, and percentage dissociation becomes only 1.414%. So in this way, you have to remember this is the percentage dissociation. So in this way, you have to calculate the percentage dissociation. So these are the some problems related to Ostwald dilution law. So in short, with the help of Ostwald dilution law, you can calculate number one, dissociation constant for weak acid or weak base. You can calculate degree of dissociation for weak acid or weak base. You can calculate concentration of X plus ion for weak acid. You can calculate concentration of OH minus ion for weak base, or also you can calculate the percentage dissociation for the weak acid or weak base. And with that here, you have to complete this problem on Ostwald dilution law. Thank you.